Hey guys, Assalamu alaikum. In my ongoing Python tutorial series, this video will be the first one to look at a one-liner programming concept, sequence comprehensions. So what are they? A definition I'd give for comprehensions in Python is that it's a short and concise workaround for generating sequences or data structures. So not to confuse you on sequences, it's another word for data structures, since a data structure can also be described as a sequence of items, and they are also called iterables, since we can iterate over them with loops. Speaking of loops, you can see an interesting code block here with the variable myList. Analyzing this a bit, you'll see that these squared brackets contain some for loop code inside. I for I in range 8. If you guessed that this generates a list of numbers, then you are quite correct. Printing this out to the console shows our list with numbers 0 to 7. So what we did here is apply list comprehension to generate a list of numbers. Pretty cool, eh? And if you watched my last video on built-in functions for iterables, you may remember that another way of generating this result would be to cast our range of numbers to a list. So applying that here and printing this out would give us the same result below. So what's the point of using list comprehension, you may ask? Well, we can accomplish a lot more with comprehensions. For example, you can include if-else conditions inside it. So if I wanted to just get a list of odd numbers from our range here, we can simply type in an if condition following this code, if I modulo 2 equals 1. And then printing this out to the console will show a list of odd numbers here. Sweet. Now when I first bumped into comprehensions while studying Python, it was a revolutionary feeling for me. And you're probably feeling the same way, most likely because of how we just used one line of code to do what could have been done in probably 4 to 5 lines of code. Let's translate this comprehension to a traditional form that we've worked with before. We'd first mention an empty list to collect odd numbers from our range, then apply the actual loop for I in range 8, under which we'd have an if statement to fetch the odd numbers, and inside it, we'll append an odd number to our empty list. By the end of the loop, we'd have the same list of odd numbers generated as shown in the console. Now you can see that generating this list not only took a little more time, but also more lines of code, and an extra variable to make an empty list here. So all of this can be compressed to a comprehensive list as we did here, which makes life a lot more easier. Alright. We can also apply comprehensions on sets, tuples, and dictionaries. Let me just remove this loop code here and change this variable name to sequence. And then let's replace these squared brackets here with curly braces so that we'll have a comprehensive set. And then let's print out sequence to the console. You'll find that we have a normal set of odd numbers generated in the console here. Cool. So we've just applied set comprehension, and let's try doing that now with normal brackets here. So you may think that we're applying tuple comprehension now, but if you print this out to the console, we'll see a weird object here. So this is what's known as a generator object, which we can confirm with the type function that it's of the class generator. Now I'll go more in detail about generators in a separate tutorial, so for now I'll just briefly explain them. They are known as lazy iterators, which means that they can produce your items only when asked for. So our iterable is in a frozen state, and this state is called a generator. So we can iterate over generators anytime using for I in sequence, print I, which show our numbers printed out to the console here. Now the big difference between a generator and the other comprehensions is that generators, when produced, are not stored inside your computer's memory. In the case of making a list or any other comprehension, your full list of items are loaded into memory at once. Therefore, you're able to see the items of your collection in full here in the console. So loading everything into memory can be an issue sometimes. Say if I had a huge list of items saved in a file, loading it all to Python may take a lot of time, and the worst case would be to run into a memory error, which happens due to loading huge amounts of data to your memory. So there can be a risk of slowing down your computer, or maybe even crashing it. So you then have to restart your PC to go back to where you left off. So this is one use case for generators in working with huge amounts of data. In our case, however, working with a small range of numbers here should not give your PC any memory issues. Alright, so basically there isn't any tuple comprehension in Python so far. You can, however, convert this generator into a tuple via casting. And this way, we get our tuple of numbers here below. Awesome. Now moving on to dictionaries. To generate a dictionary via comprehension, we can use curly braces as we did for making a set. However, this only produces a set, so we'd have to make key value pairs in some way to get our actual dictionary. Let's make a collection of key values. I'll simply make a set containing tuples with duplicate numbers, where the two i's here present a key and a value, and our set will look like this. Now let's make a new variable, myDictionary, and we'll apply the comprehension inside curly braces here, with counter variables I and j separated by a colon. The ij values will get a key and a value respectively from our set of items. So in detail, I and j here will fetch the two numbers inside the first tuple of our set, which translates to the first key and value in the new dictionary. And the next iteration will make a second key value from the second tuple inside our set, and so on. By printing out my dictionary here, you'll see that we successfully made one via comprehension. Awesome. So this is how dictionary comprehensions work, where counter variables have to be defined in key value form here, and these counters will then fetch each key value simultaneously from a collection of the pairs. Alrighty. One last thing to mention about comprehensions is that we can't use else conditions at the end here after its if statement, and else if can't be used at all inside comprehensions. One way to apply an else condition is by first stating your if condition right before this loop, then following it with your else block. So let's make this a list comprehension, and what I'm doing here is getting our odd numbers again from the range, now with an else condition that will catch any even number, and this string will replace each even number in our list. So let's just apply this object to the sequence variable, and then print sequence out to the console. You'll find a list of numbers and strings in our new list, showing that each even number has been replaced by this string, and the rest are just odd numbers contained here. Super. So this is one thing to keep in mind regarding if-else conditions and comprehensions. If you'd like to use both if-else statements inside them, you can simply apply the conditions as a one-liner after your counter variable here and before the for loop. But if you'd like to just use an if statement, you'd have to then place your if block right after your loop section with no else block here. Aight. So that's pretty much it on comprehensions that I wanted to cover for today. We've now reached the end of this video. Comprehensions are quite amazing, and I personally use a lot of them in my Python projects, which keeps my code minimal and efficient, which makes quite a relaxing experience. Alright, for the next few videos, we'll be looking at user-defined functions and maybe some more cool built-in functions in Python. I hope this video was helpful for you. If you enjoyed it, give it a like or a subscribe, and hoping to see you in the next one. Thank you so much for watching. Take care, and assalamu alaikum.